Hi guys, today I'll be teaching you about vectors. Vectors is a very broad concept in physics. So it is used in forces and motion, and you'll see many examples of it. Without vectors, it's almost impossible to understand those chapters at a higher level. So for example, let's start. In a normal math class, your teacher might say, "What is the speed of this car?" Well, you might say, ma'am, it's distance over time, or sir, it's distance over time. You're not wrong because, but have you ever wondered the speed is in which direction? If a car is moving, for example, here, okay, and if a car is moving in this direction at a speed of 5 meters per second, and you say, ma'am, the car is traveling at 5 meters per second. Well, you don't know either the car is traveling left or right, but in reality the car is traveling right. To get a sense of what I mean is, for example, in a basics physics class, now from maths to physics, in a basics physics class, for example, there's a force of 5 newton acting on an object, for example a car, and then another 2 newton force in the opposite direction of the 5 newton. Well, you know that the net force acting on the car is the sum of 5 newton is the sum of both these forces. Let's call this force F1, let's call this force F2. You say that the sum of these forces is F1 plus F2. You're not wrong. But the problem is an ordinary student who hasn't studied vectors might say, "Oh, it's 5 plus 2, it's 7." It's wrong because what happens is 5 Newton is acting that way, 2 Newton is acting that way. It's an those are in opposite directions. The answer must be F1 plus F2, and F2 will be negative. It will be negative 2 Newton because it is acting in the leftward direction. So it will be 5 Newton plus minus 2 Newton, which will give us 3 Newton. This is the correct answer. This is the wrong answer. So this was common sense. Anybody could answer this question and say it's this minus that. So in vectors, you'll go into details of directional properties. So in this question, when I said what's the net force acting on the car, what's the total force acting on the car? Some would say, sir, it's the force acting, it's 5 Newton plus 2 Newton, where we have to take into consideration that 2 Newton is in the opposite direction. Scalar, so vectors are specific physical quantities. They are physical quantities. Physical quantities are of two types: vectors, which are these, and scalars, right? Scalars are those which can be completely described by their without direction. They can only be described with magnitude. Magnitude basically means the value. For example, 5 meter per second is the speed of one car. You don't require the direction, so so the teacher might say, oh, it's correct. But for example, it's asking for the velocity, which is a vector. They're asking for the velocity, it's a vector, and you write 5 meter per second. I remind you that this is only the magnitude. Direction is not present, so it will be wrong. Okay, you have to specify the direction, and that's why vectors are all over in physics, because physics deals with forces and motion, and without vectors every physicist would be like banging their head. So let's get started. So vectors are quantities which have a magnitude, a value, and and a direction. They can be described by these quantities. Vectors can be described by these two figures, right? Scalars can be defined without direction too. So um, you know what is a vector now. For example, now in a notion form, When in physics you might see a vector like this means that for example, it's given a magnitude of 5, and it has a magnitude of 5 and its direction is toward the right. It's in the rightward direction. And for example, another vector is given here. Its magnitude is 3 and it's also in the rightward direction. Then you will add, and for example, the question asks you to add these vectors together. You know that they are in the same direction, right? So you will get an answer of 8. 5 plus 3 is 8. But you won't do the same thing when I, for example, give you a vector which is 5 and one vector which is 3. You won't add because this is like northeast, and this is towards the east direction, right? So you can't add a vector quantity without having the same direction properties. This means that direction plays a very important role because it defines half of the vector quantity, right? So for example, a vector of magnitude 5 is given here and a vector which is going here has a magnitude of 3. Well, you might say that the 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 net vector is 2 in the rightward direction because 5 minus 3 is 2. But we're not doing 5 minus 3. We are not doing 5 minus 3. Instead, we are adding those vectors, but the second vector has a negative sign. In this one, the second vector has a plus 3 sign, but we are subtracting them without knowing that the this vector has a negative sign. But in reality, this is correct because when we deal with vectors, rightward is considered to be positive, leftward is considered to be negative. Similarly, upward is considered to be positive and downward is considered to be negative. And just like the coordinate system, upward is positive, downward is negative, leftward is negative, and rightward is positive. So if I say that, uh, sorry, if a vector is, for example, 3 here and 5 here, so 3 plus minus 5 will be the will be your actual sense. You will write this equation in your mind. You might write 3 minus 5 in the exam, it's correct, but you need to know that this vector has a negative sign associated with it. And when you find the resultant vector or the net vector, you add those vectors together, but but the vectors have signs associated with them. That is an important point to remember. Now let's get into resolving of vectors. Okay, let's resolve those vectors. Resolving a vector basically means, for example, I have a vector in this direction of a magnitude 5. So you know that if a car is moving, for example, a car is here, it's moving in this direction. Okay. So you know that the time it takes to the car during this journey, it's covering some distance in the rightward direction and some distance in the northward direction, right? So while it is traveling here, the distance in the x coordinate is increasing and the distance in the y coordinate is also increasing. So basically resolving of a vector basically means breaking the vector up into its components, into its x component and into its y component. So for example, my x component is 3, for example, and whenever you resolve a vector, it would obviously be a right angle triangle because the the degree between a x coordinate system and a y coordinate system is always 90. That's common sense. So for example, 3 is the x direction. What will be the y vector? Now this is simple math. Whenever you think of vectors, mathematics doesn't change, but the approach you apply to that question definitely changes. So it the we apply the Pythagoras theorem here. Y square plus 3 square is equal to 5 square, and you get y as 4. You get y as 4, and it's in the fact that it's in the upward direction means that it is 4. Now You might be thinking that I could have drawn the vector like this and this, but it doesn't make sense. See, the take this as a car. The car is moving upward, but we have drawn a vector which is downward here. So the method I have used here is head to tail method. So this is the tail, this is the tail, and this point is the head. So I basically joined those two parts to create the resultant vector. Okay, so for example, in this case we were given the resultant vector and this x component. What if we're given the x component and its y component when we have to find the resultant vector? We'll apply the Pythagoras theorem again, and we'll do the sum. Now one problem is here. Actually, that's not a problem. That's like each of each of these quantities y, x, and r have to be represented with an arrow on the top. A vector is represented by an arrow. So, for example, velocity is a vector. I won't write v. I would draw an arrow on top of that, symbolizing that I am writing it in the vector form. Or if you just want to specify the magnitude of a vector, for example, you know that velocity is a vector, and you say 5 meters, right? There's no direction. So in order to make this vector a scalar in a scalar donation, you just add two bars here, specifying we're only specifying the magnitude of this vector. Okay, so remember to draw those arrows on top so that the teacher knows or whoever knows or you know that's a vector. Don't get confused. So these are the basics. I'll give you one question now, and you have to solve it. So before you do the vectors, before you watch this video, I recommend you learn all about trigonometry, inverse sine functions, and stuff like that. Just learn a basic trigonometry ratio, for example, SOHCAHTOA, that thing. Because in vectors we will be using sine, cosine, and tangent a lot. So please learn them and come. I'll give you a question now. This is a vector which okay, this is 30 degrees, this is 5. Okay, and this is find its x component and y component. So to find its x component, we'll be doing cosine of 30 is equal to x upon 5, and 5 will go there to make, and 5 will go there to make 5 cosine 30 will be x. I write my solutions in a different color. So this will be my solution. 5 cos 30 will be equal to x, and to find the y component we just do sine minus 30. Here comes the problem. When you study trigonometry, you know that you have a unit circle, and whenever you go, for example, an angle here, you find it as theta, but when you go downwards it is negative theta. So the same case is applied here. So we follow a convention in physics, and it's a logical convention. When you go clockwise, when you go clockwise, the angle is negative, and when you go anti-clockwise or counterclockwise, anti-clockwise, you will get a positive value. So in this, without remembering this convention, you can just like apply some logic here, that if the resultant vector is going down, so is going down in the eastward direction, and going in the south direction, so its y component will be southward, and its x component will be eastward. It's simple, right? So sine of minus 30 will be equal to um Sine of minus 30 will be equal to y upon 5, which will be 5 sine 30 will be equal to y, and sine minus 30 is just minus 0.5, which gives us 2 minus 2.5 is equal to y, and uh, cos 5% 30 you can easily do with the calculator. So these are the basics of vectors. Now, sorry, I take too much time for erasing and I can't do anything about the software. So please recommend if you have a better software for creating tutorials. I tried to implement Khan Academy, and I recommend you to go there as well. It has amazing physics videos. It's basically the best for almost all subjects. Go there, try it out. It's amazing. Now I'm gonna give you, so vectors is just about this. You don't need to learn like the 6 types of vectors. Those are not necessary. You just have to learn this. And even the like the triangle rule and the parallelogram rule, that's not useful. You just apply some logic in your you just apply some logic to solve problems. Now we're gonna solve a slightly tough problem, not so tough, to end this video. So basically, the problem which I will be giving is from a book which is named as Resnick Halliday Walker, Fundamentals Fundamentals of Physics by Resnick Halliday Walker. So you can easily buy it on Amazon. It's called Principles of Physics by Resnick Halliday Walker. It's quite a famous book, and basically it clears a concept so good. It has some Olympiad level questions you can attempt. I totally recommend it for you. And yeah, it can be used to clear concepts of like 12th grade and stuff. It has quantum mechanics, relativity. It's quite good. So but before you learn relative before you go into Resnick Faraday Walker, I want to ensure you that please learn calculus. It would be very beneficial. Please learn calculus. I will be creating tutorials on calculus as well, because for physics, calculus is like the even if math is the language of physics, calculus cooperates for 99% of the physics language, right? So calculus is very important. So try to learn it. I'll be creating tutorials on differentiation shortly, and chain rule, product rule, quotient rule, etc., etc. Now let's do the question on this vector problem. So our first vector is this. It has a magnitude of 3.66 meters. Now the our second vector has a magnitude of uh, this southeast, and it there's an angle of 45 degrees, and its magnitude is wait, I can't read. It's 1.83 meters. The third vector um, has a magnitude of what's it called, 0.91 meters. 0.91 meters. And so basically our aim is to find this resultant vector right here. So this is a question directly taken from Resnick Halliday Walker. Please like and subscribe. It's too abrupt to say that, but yeah, please like and subscribe. Now I'm gonna solve this question, and this is 90 degrees. To ensure you that this is not just solve this question. What was I saying? Sorry. So solve this question. So first I'm going to solve this question. So first, in order to I'm going to prove something to you, that you've got a resultant vector, for example, and for example the resultant vector is the sum of two vectors, a vector and b vector. Okay, resultant vector is denoted by r usually. Okay, so can we state that the x component, the horizontal component of the resultant vector, should be equal to the horizontal component, the sum of the horizontal component for each of these vectors, right? So for example, I make this vector and I make this vector. This is vector A, this is vector B, this is the resultant vector. So I can say that this is vector B. So I can say that the x component of this vector plus the x component of this vector should be the x component of this vector. So similarly, if the x component can be present, the y component should also be present. So ry should be equal to ay plus by. Don't forget the arrow sign right here. So this is the principle which we would be using in this question, that we would break each vector into its components, and we will add each of these components to find the net x component and the net y component. Then we will use basic Pythagoras theorem to figure out the resultant vector. So first, this is, let's name this vector a, b, and c. So let's find. I'm gonna erase this, and I'm gonna change the color of my pen. Come on, red. I choose red because normally I make videos with red because it's bright. Okay, so let's find the x component for this a vector right here. So this is my vector a. Sorry for the bad drawing. This is my vector a right here. It's vertical. So if you apply logic, when a car is going like this, it's making no progress in this x direction. It's just making progress in the y direction. So obviously vector a is 90 degrees from the positive x-axis. That means it doesn't have a x component. So basically the x component of a will be 0. Now in order to prove it, I can like prove it to you that um the there's a 90-degree angle right here, and if I want to find the x component, I would just do like cos 90 degrees, right? And basically sine 90 degrees, and I would get the answer as. So basically, um if I want to prove it, it will take like a lot of time to prove it. So actually uh wait. Yeah, actually I should prove it, I think. I was looking at my book for something, sorry. So to find the x component in the previous vector thing, we said that cos of the angle times the 3.66 will give you the times the 3.66 means the this thing, this vector. You add it, you multiply it by cos 90, and you will get 0 because cos 90 is 0. So eventually the you can check with the calculator, cos 90 is 0. So you will get the x component as 0. So we will write it as ax is equal to 0. Now for vector b, this is vector b. For vector b, we'll say that this is vector b right here. It is um, it is 1.83 meter long, and it is 45 degrees. To find out the x component, we do cos 45 times 1.83. 1.83 times cos 45. This should give you a value of, let me check with my trusty calculator, fx 82 ms 1.83. I think you'll get a value of 1.29. Let me check again, or you guys will sue me for this video. Yeah, 1.29 rounded off value. So the 1.29 meters, don't forget meters, and 1.29 meters is the value of this in the rightward direction, so I'm making it positive. And um, so bx will be equal to 1.29 meter, and let's take out the value of cx. Now cx is, let me say, Cx. Cx has a value of 0.91 meters, and if we have to divide it into its components, we'll do this, we'll do this. This will be 90 degrees. If this is 90 degrees, so wait, what am I doing? Sorry, what? So this is the south direction, this is the south west direction, so this will be 45 degrees. So to find the x component, i do I do sine 45 is equal into 0.91, and it will be minus 45 because the value of x is in the leftward direction. So when I do this, sine minus 45 answer into 0.91, which will give me minus 0.643. So sorry for the bad handwriting, by the way. See, x will be minus 0.643 meters. So we can say that the resultant vector's x value is the sum of these x values. So 1.29, 0 plus 1.29 plus minus, so 1.29, 1 point, what? My calculator is shitty. Plus minus 0.643, 0.643, which will give me, I believe, 0.647. This is my resultant vector x value. Now I will use this space to find the resultant y value. So let's get started. So my resultant y value for this 3.66 meter will be 3.66 meter because our x value was 0, so this would be obviously 3.66 meters. Then the value of by of this would be um the value of this 1.83 would be sine 45 minus 45 because it's downward, um into 1.83. So sine of minus 45 will give some random value 0.83 minus 1.29, minus 1.29, and the last one will give me a value of the last one. Where's the last one? Yeah, here's the last one, 45 degrees. So cos 45 minus 45, yeah, because it's downward, into 0.91. Wow, so less. Cos minus 45 into 0.91, which will give a value of minus 0.707. Well, if you do cos minus 45, you'll get a positive value because the it doesn't matter when it is negative or positive. It's a trigonometric identity. So basically the logic is like, what I did in this thing is I took the value in this way, 45 degrees. I should have taken this value because cos theta only applies and sine theta only applies when you take it from the positive x-axis. So if I had done cos cos minus 135, I would have gotten a negative value, which means that the values are same. Okay, the answer would which you would get will be same. but the difference is that I just use some logic. So you can do any type of things. So yeah. So I'm going to take out this value, which I believe I have 0.707. Wait, let me check. Uh, Wait, what? Oh, it's a wrong value. I forgot to multiply 0.91. So it would be minus 0.643. I'm gonna add these up to find ry, and this should give me 3.66 minus 1.29 minus 0.643. Wait, 3.66 minus 1.29 minus 0.643, which will give you 1.727, a positive value. So basically the resultant vector would look like this. This is 0.647. This is 1.727. We have to take out this thing. So Pythagoras theorem can be applied here. 0.647 squared plus 1.727 squared square root of answer, which would give us 1.84 meters. Here's our answer. We got our answer finally. Resultant vector will be 1.84 meter. Drum roll. Yeah, I got my answer. You can find the angle. You can find the angle here by just like doing for example, you can find this angle by doing tan theta. So yeah, you can easily do this. Tan theta will be equal to this upon this, and you can do tan inverse. So this is my value, 1.84 meter. It is correct according to the Resnick-Halliday book. If any objection, please put in the comments below. I hope you like my video, and don't forget to subscribe. This is about it, vectors. We'll be doing more. These are one of the detailed questions. So if you're able to solve it, it's good. When you will do forces, it would go into more detail. So forces and motion will be in a different tutorial. I hope you like this video, and don't forget to subscribe.